All right, let's just jump right in. We are standing right on the cusp of a huge shift in artificial intelligence. We're moving way beyond the AI we know today into something that's way more active, way more autonomous. We're talking about the rise of AI agents.
So think about it. For the past couple of years, AI has been this incredible conversation partner, right? It can answer your questions, it can write an essay, it can even generate images. But what if it could actually do things? What if you could give it a goal and it could see that goal through to the end all by itself? And this right here, this highlights the crucial shift. We're moving from what we call predictive AI, which is basically designed to give you an answer, to autonomous agents, which are designed to accomplish a goal. It's the difference between asking, hey, what's the weather, and saying, hey, book me a flight somewhere warm. One gives you information, the other one takes action. Now, you got to understand, this isn't just some new feature they've bolted on. Not at all. This is the natural evolution of the language models we're all getting so used to. Agents are the thing that makes all that incredible reasoning power actually useful inside our software, inside our lives. Okay, so how do we build one? Well, an agent isn't just one single thing. It's a whole system. I like to think of it like building a bionic teammate. It needs a brain, it needs hands, and crucially, it needs a nervous system to connect the two. So let's break down that anatomy. First up, you have the model. This is the brain. Pretty straightforward. It's the large language model, the LLM, that's at the center of it all. This is the part that does the thinking, the planning, and all the decision-making based on whatever information it has. But, a brain floating in a jar isn't all that useful, is it? It needs a way to actually interact with the world. And that's where tools come in. These are the hands of the agent. They're things like APIs and functions and databases that let the agent take real action. To go search the web, check a calendar, send an email, or pull data from a database. And finally, we have the orchestration layer. You can think of this as the nervous system. This is the absolutely critical process that's always running in a loop, connecting that brain to the hands. It manages the entire cycle of thinking, acting, observing the results, and, this is key, it's what gives the agent a kind of memory to learn from what it's doing. So now, let's get to the real core of how these things behave. That nervous system we just talked about, it runs on a continuous loop that lets the agent solve problems. So let's take a look at how that actually works. Just about every agent out there follows the same fundamental cycle. First, it gets a mission from you. Then, it kind of scans the scene, gathers some context. Next, it thinks through a plan of attack. After that, it takes an action using one of its tools. And finally, it observes the result and iterates, just repeating that loop over and over until the mission is complete. This whole thing is often just simplified to think, act, observe. Okay, that's a little abstract. So let's make it real. Imagine you ask a customer support agent a super simple question: where is my order? Now, a simple language model might just make something up, right? It might hallucinate an answer. An agent, on the other hand, starts a whole process. So let's peek inside the agent's brain here. First, it thinks and makes a plan. I need to identify the order, track it, then report the status. Simple. Then, it acts, calling an internal tool to find the order. It observes the result, which gives it a tracking number. So it acts again, this time using an external shipping tool with that new info. It observes that the package is out for delivery, and only then does it put it all together to give you a complete, fact-based answer. Now, it's really important to get this. Not all agents are created equal. Just like with any other piece of tech, there are different levels of capability. They range from a simple little problem solver to a whole complex collaborating system. And understanding these levels is really the key to seeing where all of this is going. Level 1 is where the magic really starts. This is where the brain finally gets its hands. A Level 1 agent can connect to an external tool, like a search API. So if you ask it about last night's game score, which is something totally outside of its training data, it can now just go look it up and give you a real-time answer. Now, at Level 2, the agent becomes a strategic planner. It can create and actually execute multi-step plans. So for example, if you ask it to find a coffee shop halfway between two addresses, it first uses a maps tool to find the midpoint, and then it uses a places tool to search for coffee shops in that specific area. See? It's carrying context from one step to the next. That is a huge leap. And this is where things start to feel really futuristic. At Level 3, we stop thinking about a single, all-powerful agent that does everything. Instead, we build a team of specialists, A whole system where different agents collaborate, and each one has its own expertise, just like in a human organization. So, for a big mission like launch our new Solaris headphones, a project manager agent doesn't do all the work itself. Nope. It acts like a real director, delegating specific subtasks to specialized agents. It'll tell the market research agent to go analyze competitor pricing. It'll tell the marketing agent to draft some press releases. And it'll tell the web dev agent to generate the HTML for the new product page. This is how complex end-to-end business workflows can actually start to be automated. Now, this all sounds amazing, but there is a huge practical challenge. How do you take these powerful, but let's be honest, sometimes unpredictable systems and make them reliable enough to use in the real world? Well, this requires a whole new discipline that people are calling agent ops. And that really brings us to the central question, doesn't it? An agent's greatest strength is its flexibility, its ability to reason and adapt to new situations. But that exact same flexibility is what makes it unpredictable. So, how do you build trust in a system that doesn't always behave the same way twice? The answer is we have to fundamentally change how we think about building software. We have to move away from simple pass or fail tests and start evaluating for overall quality. We can't use the old school breakpoints to debug. Instead, we have to analyze entire reasoning traces to see exactly where the agent's logic went wrong. We're moving from a world of hard-coded logic to a new world of guided autonomy. So what does this all add up to? When you combine this insane reasoning power with real-world tools and a totally new way of making sure it's reliable, well, the future of how we interact with technology starts to look very, very different. It starts to look a lot more collaborative. And the crucial point here is that this is so much more than just a fancy new term for workflow automation. We are building systems that can function as genuine partners. These agents are becoming adaptable, capable, and intelligent new members of our teams, ready to take on complex goals right alongside us. And that leaves us with a final, fascinating question to think about. Once we have partners that can reason, act, and collaborate at a massive scale, the kinds of challenges we can even attempt to tackle, they change completely. So the real question isn't just what AI agents can do, it's what new, bigger problems are we going to solve together?